Hello and welcome. I'm Praveer, and I'm going to share thoughts today on abundance through quantum computation. As we go through this presentation, please keep in mind the following quote by Marcel Proust. The real voyage of discovery consists not in seeking new landscapes, but in having new eyes. And the reason why I bring this quote up is because the perception that is offered through this presentation is different than the mainstream perception that is driving the development of quantum computation. So please keep that in mind as we go through this. I want to go over some objectives, and then we'll dive into seeing quantum computation differently. We'll get into a conception of abundance, that this different vision of quantum computation surfaces. We'll summarize a path to abundance, and then we'll conclude with some summary and takeaways. So the key objectives here are to inquire why quantum computation is an ideal candidate to increase abundance, and what is the trajectory toward abundance. Now, keep these in mind as we go through, but there's also a number of other objectives that I'll circle back to at the end of the presentation. And these are the following. What's the connection between quantum computation and genetics? What's the connection between quantum computation and AI? How will quantum computation change the foundations of material sciences? How will quantum computation enhance the management and maintenance of life? How might quantum computation connect us to an undying source of energy? And finally, how might quantum computation enable interstellar space travel? Of course, these are all big topics in themselves: genetics, AI, material sciences, maintenance of life, source of energy, space travel. And here, what I want to do is just draw the initial connection between quantum computation as perceived in this alternative perception and these areas that themselves would contribute to the notion of abundance. So let's dive into seeing quantum computation differently. To start with, here's a question. What's the origin of today's quantum computing industry? Now, consideration of this is going to yield a different trajectory that we're going to get into. So there's a genesis of an alternative trajectory when we consider the origin of today's quantum computing industry. So Dr. Richard Feynman is considered to be the father of the quantum computing industry, and he proposed a quantum computer that would imitate nature. And this, of course, has been instrumental to all developments and the developmental trajectory of quantum computing. But diving into it a little more, his belief was that nature is probabilistic and that imitating the quantum mechanical dynamics of nature will confer computation with extraordinary power. And that remains the goal of today's quantum computing industry. But there's potential issues with this approach. After all, is nature entirely probabilistic? Or is there some kind of level of determinism, or is there some other kind of dynamics that are taking place? And again, when we say imitate quantum mechanical dynamics of nature, what exactly are we imitating? Our interpretation and perception of quantum mechanical processes are, I would say, at the very, very beginning stage, and our interpretation of phenomena like superposition and entanglement leave questions. Are they the right interpretation? So these are things that need to be considered. So what, therefore, is foundational to this is there another interpretation of nature, and what exactly is being interpreted? Because if that's the case, then there's a different trajectory that would be required to really get to the kinds of possibilities that industry today says that quantum computing can deliver on. So what are some ways around this? It's to get pretty fundamental here. It's to be able to read what's happening at the quantum level and then build computing architecture based on that. So fundamentally, what I'm suggesting is that we create some kind of microscope, and I call it Nano-Cyborg, and you'll see why. And that this then becomes the starting point of an alternative trajectory. So when we consider the idea of reading, then the first point to be made is that reading will be enabled by seeing nature as a single system. So we know that all quantum particles are sourced from the quantum levels. All atoms are sourced from quantum particles. All molecules are sourced from atoms. All molecular plants, which is the basis of living cells, are sourced from molecules. So it's evident that there's a tight integration between one layer of nature and the next. So the question is, why don't we also study it as a single system when trying to get insight into one layer or another? So if we want really to understand what's happening at the quantum level, the proposition here is that we need to consider other layers of matter and life as well to truly gain insight and to build the right architecture to leverage quantum phenomena. Now here I'm going to propose a way to get a sense of what we're trying to read through a process of reverse extrapolation. So what do I mean? This is a depiction of a living cell, and the cell could be an animal cell or a human cell or a plant cell, but something that is common across all these living cells is molecular plans, and there's 4 molecular plans that are common to all these living cells, and those are, we know them as nucleic acids, polysaccharides, lipids, and proteins. But if we try to intuit what really each of these stand for, then we can perhaps say that nucleic acids, which creates DNA and creates the library and information in a cell, perhaps is a carrier of something we can call knowledge. If we want to say what does polysaccharide stand for, then we know that it delivers power and energy to the cell. So it's a carrier of some kind of power or energy. Lipids create natural compartments in cells, and through that compartmentalization allows work specialization and harmony. And therefore, we may say that lipids are a carrier of this thing that we're calling harmony. And proteins, we know, for example, in a human cell, there are over 30,000 different proteins that each has a specific task, and they provide overall something that we can call service or presence in the cell. So we're seeing that the 4 molecular plans that exist, perhaps if we step back, then the pattern that really we're seeing is one of knowledge, presence, power, and harmony. Now let's go down a level of granularity to the periodic table. And here, the 108 known elements can be classified scientifically into S shell, D shell, P shell, and F shell elements. But let's ask what these stand for. So if we look at some typical S shell elements, we have hydrogen and helium, which we know power suns. They create nuclear fusion, and all stars, all suns in the galaxy, the light, the heat that's generated is due to these. So we can say that S shell is perhaps a carrier for light or a property of power or energy. We can say that D shell, so D shell elements, things like iron, nickel, cobalt, steel, aluminum, and so on, these are workhorse elements. They create the infrastructure all around us. And so we could say that these elements, or the D shell, is a carrier of something that we're calling presence or service. If you look at F shell, this is clearly an experimentation and collectivity at the atomic level, because we have atoms that have large atomic numbers. And so we could say that this is a carrier of the idea of harmony. And if we think about P shell, we have elements like silicon and carbon that are the basis of thinking machines, quote unquote, thinking machines and human mentality. And also there are other archetypes that exist across the periodic table in the P shell. And so we could say that this is a carrier of knowledge. So again, just as we saw in the cell, we're seeing here in this layer of matter arise this fourfold pattern of presence, power, knowledge, and harmony. So let's go even further to a deeper level of granularity. And here, this is a standard model, which all quantum particles are classified into. So we have here quarks. And quarks, interestingly, are the only component of something that's called protons. We know that protons, depending on number of protons, that will distinguish or that will describe the atomic number of an atom, and based on the atomic number, we have the precise behavior of that atom. We know, for example, if we have 47 protons in the nucleus, then essentially what that means is that atom is silver and it's going to behave as silver regardless of where it goes with certain defined properties. If we look at leptons, and here we have an electron that's a surrogate for the lepton class, and we know that the electron is present in all release and exchange of energy, and therefore we may say that leptons are a carrier of this idea of power or energy. When we look at bosons, we know that all other quantum particles are bound together by the action of bosons, and so we could say this has to do with harmony. And if we look at the Higgs boson, we know that any quantum particle that has mass has so by interaction with the quantum field, and therefore we can say that the Higgs boson has to do with presence. So we're seeing the same pattern over here from this point of view that we're seeing at the cell and in the periodic table. So the question is, where does this pattern come from? And what I'm suggesting is that it comes from the quantum levels. So this same pattern exists in root form at the quantum level, and that's going to provide us a clue on what to look for and how to read the quantum level differently. So what I'm just stepping back, what I'm going over is components of an alternative trajectory. So we've looked at the idea of reading the quantum level differently, but now the question I ask is, what is the most functional ubiquitous quantum computer? And why would that be important? Because ultimately, in this presentation, what we're suggesting is that quantum computation can really influence and affect abundance. And if there's something that's ubiquitous that's a quantum computer, then automatically that ubiquity is going to be definitional to abundance. And so understanding if there's a functional ubiquitous quantum computer becomes important, because if we can change that or if we can affect it, then we have an inner door into affecting abundance. So here I want to suggest that the atom is in fact an example of a ubiquitous quantum computer. Why? So why is the atom a quantum computer? Well, we know that the nuclei are created from quantum particles, so quarks bonded together by bosons, another quantum particle. We know that electrons, another type of quantum particle, exist in stable orbits around the nucleus. And further, electrons exhibit superposition because they can exist in multiple superposed states. Further, we know that, as I shared earlier, that if you have an atom of atomic number 47, then regardless of where it exists in the universe, it's going to share the same behavior, and therefore there's some kind of entanglement happening. And so we don't necessarily need to create entanglement from the bottom up, but there's the possibility that it may already exist and we just have to learn to tap into it. And further, this atom is in a persistence dynamics of quantum computation, because as it gets, or as light impacts an atom, then it changes the atom state, and then there's an output of kind. So input, processing, and output, that's a definition of computation. And the fact that this is comprised of quantum particles means that atom is an example of a quantum computer. But I'll go even further to say that it's perhaps the most stable of quantum computers. Why? Well, because we know that the lifetime of quantum states, such as superposition and entanglement, endure, as opposed to manufactured superposition and entanglement that we're grappling with right now that may exist for nanoseconds. Further, we know that the atom can operate in a range of diverse environments, so that makes it robust. Further, we know that the atom is the base of molecules and molecular plans and so on. Therefore, there's inherent scalability. So it becomes then an example of the most stable of quantum computers. Now, so that's the second component or pillar that I wanted to draw attention to. So just summarizing, the first pillar was that of recognizing and reading quantum patterns that are fractal in nature, that from which matter and life arise. Second is the idea of quantum computation existing already abundantly around us in the body of atoms, molecules, molecular plans, and so on. And my third pillar I want to draw attention to is the idea of, what if superposition and entanglement work differently than imagined? The reason I say this is because our conception of them are based on basically popular models of quantum mechanics, such as the Copenhagen interpretation, where you've got an unknown or an unknowable infinite possible states that collapse into one single state when measured. But that gives us a paradox, because then we can only know things when they're measured, so we can never know what's really happening. So how can we even ask, and how can we ever know what superposition and entanglement are if we have no way of seeing what's behind what's being measured? Unless, of course, there's a different interpretation of quantum mechanics, in which case it becomes possible to understand superposition and entanglement differently. The example I gave earlier on silver behaving the same regardless of where it is in the universe suggests that entanglement may never have to be created. After all, even if we think about the creation of matter, we know that it all arises from a single source. Therefore, there must be some implicit entanglement that already exists. And then we see instances of entanglement in things like the fact that no two snowflakes are alike, no two thumbprints are alike, which means that already all snowflakes and thumbprints are entangled in some way. Now, superposition, we know, for example, I'm suggesting here that also it's different, and in fact, it could suggest an order to nature. Because if we think about the atom silver, we know it has properties such as malleability, ductility, superconductivity, resistance to oxidation, and so on. And what that means is that if we consider function to exist in some quantum space, then that some set of functions is superposed on the physical configuration of an atom. And that's another way to think of basically superposition. But we also know that if we were to, as dual split experiment and dual slit experiment and so on suggests, that if we were to observe some quantum phenomena in progress or quantum objects, we change the behavior of it, which means that we're superposing some kind of intent or a collective intent or individual intent into quantum phenomena. And this may also be a different way in which superposition works. But regardless, these different interpretations of entanglement and superposition suggest that nature is not entirely probabilistic. And as we know that today's conception of quantum computing is based on a specific interpretation of entanglement, specific interpretation of superposition, and the interpretation that nature is probabilistic. And therefore, questioning all these gives rise to the third component in an alternative trajectory of quantum computation. This also leads us to the idea of abundance, because if we extrapolate forward and ask if indeed the atom is a quantum computer, the question is, what exactly is it computing? So we already have a hint of that, because we know that an atom of atomic number 47 will maintain its behavior regardless of where in the universe it exists. It means that perhaps what's being computed is some kind of code that circumscribes the atom. We don't know how to read it yet, but that defines its behavior. And so it's creating, therefore, some kind of pre-genetic code that exists for the same purpose as genetic code in cells. So what we're saying here is that quantum computation creates at least some pre-genetic type code. But what are other instances of naturally occurring quantum computers? Well, we know that molecules are comprised of atoms and therefore are sophisticated quantum computers. Molecular plans, which I went over, lipids, proteins, polysaccharides, nucleic acids, are chains of molecules and consequently even more sophisticated quantum computers. Then we have cells comprised of these four molecular plans that by definition then are also quantum computers. So what are cells computing then? So they are computing genetic code, the genetic code that maintains the integrity, possibilities, and boundaries beyond which cell breakdown occur, and then perhaps also new genetic code based on inputs, environments, and interactions that they have organically. So what we're saying is that genetic code, genetic type code, then is the output of quantum computation. So what's the implication then of that? If that's the case, if these naturally occurring quantum computers are always creating genetic type code, what's the implication of that? Well, it has a link to do with AI. And specifically, what I'd like to draw attention to is that we can think of the codification that we see at the different levels of matter and life that arise, quantum particles, atoms, molecular plants, cells, as codifying some intelligence. And progressively, there's more intelligence that is surfacing in each of these different constructs. So what's the implication of that? Well, what that would imply is that then there may be some repository of quantum intelligence that's native to the quantum levels. So this then becomes a different kind of quantum property beyond superposition, beyond entanglement, something that we could call quantum intelligence. So in this point of view, quantum intelligence is a native property, and the surfacing of more complex natural computers, such as atoms and cells, exists to allow more of that intelligence to materialize. But given that, what insight would that give us on AI versus QI, quantum intelligence? Well, AI, we know, is a subset of human intelligence. It's conceived and it leverages a subset of conceptual mechanisms that derive from human intelligence. But human intelligence itself is an outcome computed into existence and housed in a human being from native quantum intelligence. So by definition, quantum intelligence is probably vastly more intelligent than all instances of intelligence that arise from it. So if we want to create the next device that houses a different kind of intelligence, AI will certainly give us something, but then also we would need to be able to tap into quantum intelligence to create something different. So given QI, given quantum intelligence, how might we want to design quantum computers differently? Well, first of all, let's go back to the painstaking creation of digital computer. This took decades. And first of all, there was creation of computing medium that involved understanding of light. There was encapsulation of forms of light in the circuits, and then the manipulation of these circuits through carefully worked out logic. And this was an arduous effort that took decades to come to fruition. The question is, are we at the same level of understanding with the quantum level and our efforts to create quantum computation? I would say no. So we have to go through a process of objectively understanding what exists at the quantum level. We have to learn to read it, and we have to learn to appropriately leverage the intelligence that exists there. So there's a lot of pre-work that needs to be done before we go down the path of saying that we're going to build a quantum computer that imitates nature. Further, there's a natural integration, as we see from the surfacing quantum computers, between the different levels that arise from the quantum levels. And this QI type quantum computer that we're going to design also should be able to naturally integrate quantum intelligence into its functioning. And I'll refer to such a quantum computer as an integrated quantum computational intelligence device. It would be of a nano size. It would read and respond to organicness that exists at the quantum level, and it would be mechatronic, perhaps consisting of some kind of electromagnetic interface that would be able to feed back information to the quantum levels and even perhaps manipulate it to some degree. And therefore, being nano-sized and being organic and mechatronic, I'd call it a Nano-Cyborg. So we have, therefore, this IQCI integrated quantum computation intelligence Nano-Cyborgs that I'm suggesting would be required to truly tap into the quantum levels. So what could be some possibilities of such Nano-Cyborgs? Well, first of all, since we have feedback of information to the quantum level, then perhaps there's the generation of quantum patterns that can take place, and there can be some kind of co-creation in partnership with the underlying quantum intelligence. Second, since we would likely be able to affect atoms and molecules from the bottom up by changing or leveraging genetic type code that we're saying exists in all atoms and molecules. This will provide revolutionary access to the generation of materials, and it will change the foundations of material sciences. Similarly, we'll be able to affect molecular plans in cells and the genetic code they generate from the bottom up, again through the action of IQCI nanocyborgs, and this again would provide revolutionary access to the management and maintenance of life. And the biggest gain, however, may be that it could facilitate the next leap of intelligence that exists at the quantum levels into humans. And so these are some possibilities, but I want to push these possibilities even further. And if we get thinking about the quantum levels and what we've gone over in the last 20 minutes or so, then I drew attention to these fourfold patterns that exist in quantum particles, atoms, cells, and suggested also that these fourfold patterns are in root form at the quantum level, and they animate, therefore, all matter in life, and IQCI-based nanocyborgs might give a different kind of access to these fourfold patterns. And in another body of work I've done in an IEEE article from about a year ago, where I looked at the role of light-based quantum computational model in the creation of an oscillating universe, I'm suggesting that there's an even deeper pattern, a fourfold pattern, space-time energy gravity, that also is at the quantum level, that if harnessed can provide a revolution in a couple of areas. First, since we're getting into the source of this tremendous amount of energy that manifests in quantum particles, atoms, molecular plans, and cells, this may give us access to this incredible source of energy that, beyond its terrestrial uses, can also be used for extended space travel. But even tapping into these quantum levels in a different kind of way would potentially allow faster than light speeds. We already know that entanglement is happening faster than light. So we may have a more methodical access and be able to leverage this differently, which again would give access to warp speeds. The point being that IQCI nanocyborgs will allow deeper integration with quantum properties beyond superposition, entanglement, tunneling, and annealing. And in this brief presentation, I've already pointed out two such quantum properties. One is quantum intelligence, and the other fourfoldness. There's lots of others that need to be perhaps exist and need to be discovered. So it's in learning to perceive, manipulate, and leverage these that extraordinary quantum intelligence-enabled possibilities will surface. And so abundance can take on a completely different conception. Now, the path to abundance, just going over some of what we've looked at, the components of IQCI Nano-Cyborg quantum computation is, first of all, there's we can think of quanta as being a bridge mechanism between a quantum field and the material field that arises from it. And somehow the quantum intelligence is parsed out in different material phenomena such as quantum particles, atoms, and so on. But then since there's these naturally occurring quantum computers, there's a different way to leverage, and then through the process of reverse extrapolation, a different way to read the quantum level that I've already suggested. So that becomes another component of this IQCI Nano-Cyborg quantum computation. And then we have, by definition, genetic type information that's being computed into existence from each of these different types of quantum computers. And here we have atoms as an example, and we have molecular plans and cells as an example. But being able to access this, leverage it differently is another component, a key component of this alternative view of IQCI Nano-Cyborg quantum computation. So the trajectory, to summarize, is not based on assumptions of how the quantum level currently works, because this is based on a triple foundation of an interpreted notion of entanglement, an interpreted notion of superposition, and the idea that nature is probabilistic. Instead, what we're suggesting is that there's a microscope that needs to be built to see what's happening at the quantum level. And this is going to provide the basis for an entirely different trajectory of development. And there's a different kind of architecture that will be required to access and manipulate and leverage the patterns that naturally exist and emerge from the quantum level. So this trajectory is different, and I believe it would result in a rapid evolution in the understanding of quantum levels based on testing, interpretation, and generation of a range of quantum properties. So here's my quick crack. At what these quantum computers may look like, I've designed a series of different gates and the mathematics that would animate these, and filed a patent also related to this. But this is my depiction of the IQCI Nano-Cyborg from an existing graphic, and then the gates and the underlying math. So in summary, why is quantum computation an ideal candidate to increase abundance? Because quantum computation is naturally occurring and exists ubiquitously in the body of such things as atoms and molecular plans and cells. What's the trajectory toward abundance? First of all, building a microscope that will allow us to see the quantum level differently, and then taking it from there. What's the connection between quantum computation and genetics? Well, as I pointed out, all of these naturally occurring quantum computers are continuously generating genetic type code. The connection between quantum computation and AI. We can think about quantum intelligence as existing in the quantum level, and that being something that perhaps is far greater than human intelligence, but AI itself is only a derivative or subsidiary of human intelligence. And therefore, through quantum computation, we'd be able to create some kind of intelligent devices that would be fundamentally different from anything that AI would be able to extrapolate towards. And if we think about quantum computation and the access from the bottom up to materials, then it changes the foundations of material sciences. And how does it relate to management and maintenance of life? Because again, we have revolutionary access from the bottom up to genetic code in molecular plans and cells. And how does it connect to undying source of energy? Because if we can penetrate deep enough through the use of IQCI and nano-cyborgs, then we can have access to the root for full pattern, which theoretically is infinite in its display of energy, because all of matter and life arise from it. And how might that quantum computation enable interstellar space travel? Well, because we already know from phenomena like entanglement that there is faster than speed of light travel. So if we can leverage this through IQCI nano-cyborgs, then it may provide a different way to actually enable interstellar space travel. So final takeaways: quantum computation is happening all the time in atoms, molecules, and cells. We need to learn to leverage this to enable abundance. Second, there is an alternative approach to developing quantum computers by modeling the quantum levels and emergent layers of matter and life as a single system, as I've gone over. And nano-cyborgs will potentially be able to create quantum patterns, work with quantum intelligence, and influence matter and life from the bottom up. Thank you.